talk about angles and arcs today, and this is section 10.2 in your book. And the first angle we're looking at is a central angle, and it has its vertex at the center. And so we're looking at this angle ABC, where B is the vertex. This arc right here is the arc that's intercepted, and the unique thing about these central angles is that the measure of the central angle equals the measure of the intercepted arc. So when I tell you that this angle right here, ABC, is 50 degrees, you also know that the arc itself, AC, is also 50 degrees. Now, this type of angle we're looking at is called an inscribed angle. And an inscribed angle has its vertex actually on the circle. So here's the vertex E. We're actually looking at this angle DEF. And then we're looking at this angle, this arc right here, DF. Now, this inscribed angle actually has a measure that's 1/2 the measure of the intercepted arc, DF. So if we were to compare an example of what those measures might look like, if I said the angle DEF was 40 degrees, and you could say the arc DF was 80 degrees, and that is because it's inscribed. So again, it has its vertex, instead of in the middle of the circle, in the center, on the actual circle. Okay, let's talk about the different sizes of arcs. A minor arc is a measure that's greater than 0 but less than 180 degrees. And you name a minor arc by its two endpoints. So we have some examples here of minor arcs. It can come up. I have several that I've named here, so let's just look at some of them. We have this arc AB. Notice it doesn't reach that whole diameter. We have this minor arc ED. Notice I'm naming them by their endpoints. I have this arc EB. We'll change the colors from here to here. I have another minor arc CD from here to here. I have another minor arc BC right here. And then we have an arc AE. Okay. Now when we talk about major arcs, the major arcs have a measure that's greater than 180 degrees but less than 130. So if we have this arc that's greater than 180 then less than, did I say 130? 360, less than the whole circle. So let's take a look at some examples. I have this arc right here, ABD, and notice I could have called it ACD because B and C are both on that major arc right there. So you name it by the endpoints and then you pick one of the points that lies on the arc. Another example of an arc that's major is AEC. Notice that could also be called ADC. Here's another example. You have EAD, and I can give that another name of EBD. You could even call it ECD. The third type of arc that we're going to look at is a semicircle. So a semicircle measures exactly 180 degrees. And so let's look at some of the examples that come up with that. Now if it's 180 degrees, then the endpoints are going to be on the diameter because the diameter is actually the one that cuts that circle in half. That's the chord that cuts the circle in half. So one of the arcs that I could name would be from here to here. I could call it EAC, or I could have called it EBC. Those are the same arcs. There's a second semicircle on the other side. And I only gave you one other name that you could have on that. So arc EDC. So notice I'm naming it with 3 letters again to denote that it's not just a minor arc, but that it is a semicircle. So we name that third point in there. Let's look at some examples using some of these ideas now. In this problem, I want you to find the measure of angle RTS and the measure of angle QTR. So we're going to start with RTS, and we're going to look at the idea that we know that RV is a diameter. And so each of these arcs, arc RS, the measure of arc SU, and the measure of arc UV are all going to add up to 180 degrees because they form that semicircle. And also remember that central angles have the same measures or intercepted arcs. So all these central angles that I gave you, 8x minus 4, 13x minus 3, and 5x plus 5, are going to add up to 180 degrees. So let's write that equation out. There's x minus 4 plus 13x minus 3 plus 5x plus 5 equals 180. We'll combine all of our like terms. 8 plus 13 is 21x plus 5x. Let's actually put all that together. So 21x plus 5x, it's actually going to give me 26x. I have minus 4 and minus 3 is minus 7, plus 5 is plus 2 equals 180. Subtract your 2 from both sides, so 26x equals 178. So we have minus 2 here equals 180. So if I added 2 to both sides, I'll have 26x equals 182. So we'll divide both sides by 26. That gives us x equals 7. So if I want to find the measure of angle RTS, we're going to go ahead and just put 7 into 8x minus 4. So 8 times 7 minus 4 gives me 56 minus 4, which is 52 degrees for the measure of angle RTS. Now to find our QTR, I can also plug in x equals 7 into this 20 times x, so that gives me 140. Now notice, since this is a diameter, that this angle QTV plus this angle right here, QTR, have to add up to 180. So that means that QTR is going to equal 180 minus 140, which will give me 40 degrees. In this example, we've given you some information in circle P that KN and JM here are diameters, that NPM equals 46. Let's put that in there. That PL bisects angle KPM. That means these two angles right here are congruent. We also know that OP is perpendicular to KN, so I've shown you a right angle here at OPN, which also means you have a right angle here at KPO. So we're going to find each measure, and the first one is the measure of this arc OK. Well, remember that central angles have the same measure as their intercepted arcs. Okay, so if the angle is 90 degrees, then its intercepted arc is also 90 degrees. There's our first answer. Now, let's look at how we find this arc right here, LM. Notice that 46 plus this LPM plus this LPK have to add up to this diameter right here. So that means they're going to add up to 180. So since these two angles are equal, I'm going to call them X. So I can make an equation that says 46 plus 2x equals 180. I'm going to subtract my 46 from both sides. And when I subtract that, I get 134 for x. So 2x equals 134. And when you divide by 2, you should get x equals 67 degrees. Well, if the angle is 67 degrees, and that's a central angle, then its intercepted arc is also 67 degrees. The last angle I want to find here, and actually not the angle, the last arc, is this one right here, J, K, and then all the way to O. Whoops. Let's fix that. Okay, so we know this is 90. This was given to us that it was 46 degrees. We just found this one to be 67, and we knew that these two angles are equal, so that's 67. And then here, these are vertical angles right here. So that makes this one 46 degrees. Okay, so the arc is all of those added up together. So 90, and I'm going to say that all of this is 180 from K to N. So let's simplify that. That gives me 270, and then add your 46. That gives you 316 degrees for the measure of arc JKO. Let's take a detour and let's look at the circle graph. And when we do circle graphs are always made up of central angles when we're looking at the pieces and percentages of those different categories we want. This one represents the number of bikes sold in the U.S. in 2001, and we want to find the measure of the central angle representing each category. And they want us to go from least to greatest, so we're going to start with other, which is 7%. So you can take 7%, and when we write percents to do calculations, we write it as a decimal, so 7% is 7 over 100, 7 out of 100, so that's 0.07, times 360 degrees, which represents the whole circle. So we're figuring out what part of that circle in degrees is 7%. And when we multiply that in my calculator, I get 25.2 degrees. For the hybrid, that's our next biggest one. And we'll take 0.09 since it's 9%. And we want what 9% or 9 out of 100 is out of 360. When you multiply that in your calculator, you get 32.4 degrees. Comfort is our next biggest one, and 21% is 0.21 times 360. And when you multiply that out, it gives you 75.6 degrees. Youth comes next at 26%, so 0.26 times 360 gives me 93.6 degrees. And then our last one is mountain. So we have 0.37 times 360. That gives us 133.2 degrees. And then finally it says, is the arc for the wedge named youth congruent to the arc for the combined wedges named other and comfort? I don't think that one's too hard to figure it out. If you add those, 21% plus 7% gives you 28%. Youth is 26%. So those are not equal. So my answer is no there. Our last example. Our last example is going to do an example about arc length. And I've mentioned this in class, and here's where you're going to see a problem. And you're going to find problems in your book, but not very many, and it's going to be very subtle in the wording. You're going to have to know the difference when they want arc measure, which is in degrees, or the arc length, which is denoted by this lowercase script L. And we find it using this ratio right here, this proportion, that you take what the degree measure is out of 360 equals the arc length out of the whole circumference, which we find by pi times d. So notice 360 and circumference really are equivalent measures. They're just in different units. And so that's the same with degree and arc length. They're equivalent measures. They're just in different units. And when you see the word length, it cues you that they want you to find the arc length, not the arc measure. So it means your final answer will not be in degrees, but in terms of circumference, such as inches, centimeters, feet, etc. So we're going to write the ratio here. Let's look at our given information. That AC equals 9. That this angle right here, ABD, is 40 degrees, which means since the central angle is 40, then the intercepted arc is 40 degrees. So now I can actually find this length. The measure of that arc is 40 degrees, but the length will be in a different unit. So let's take 40 out of 360, so we write a proportion because 40 degrees is the degrees out of 360 for that arc. And then I want to know what the arc length is, so I write a cursive L there, script L, and out of the circumference, which is also the whole circle, such as 360, but now I'm going to represent it as pi times the diameter, so pi times 9. We'll go ahead and cross multiply those to solve. So I have 360L equals 360 times pi. Dividing by 360 actually gives me pi in this case. So L equals pi, which is approximately equal to 3.14 units. I didn't really give you a unit in this problem, but let's just say the units were centimeters. So that means this would be 3.14 centimeters. So notice I am not giving you a length in degrees, measure in degrees, I'm giving you a length in some kind of units that we might measure with a measuring tape. So as you're going through your homework and you come across problems that say find the length of the arc, please make sure that you're using this proportion. So these examples should help you get through the two assignments we have for 10.2, and that's it for now.